Have you ever wondered how your GPS just knows the fastest route? Or how a character in a video game can navigate a super complex world without getting stuck? Well, it's not magic. It's AI making incredibly smart decisions. And today, we're going to unpack the story of how AI solves these classic puzzles. At its core, the problem is actually pretty simple. How do you get from a starting point to a goal? It doesn't matter if it's Pac-Man gobbling up dots or you trying to find the nearest coffee shop. For an AI, the fundamental challenge is exactly the same. But think about it for a second. On any decent-sized map, there could be thousands, maybe even millions of possible paths. Checking every single one, that would take forever. So how on earth does an AI find the very best route so quickly? That's the big question we're tackling. Right, so the secret isn't about brute force. It's all about being smart. Instead of searching blindly and bumping into walls, AI uses what we can call educated guesses to slash the number of options and focus only on the paths that actually look promising. And that brings us to the most important word you're going to hear today, a heuristic. It's just a fancy term for a rule of thumb or an educated guess. It's a way to estimate how close you are to your goal. Kind of like when you look at a map and think, that direction feels closer. It might not be perfectly accurate, but it's a brilliant shortcut. So with that in mind, let's meet our first algorithm, which relies completely on this idea. We're going to call it the greedy algorithm. Just picture an impulsive, really optimistic explorer who always takes the path that looks like the quickest way to the finish line. Its strategy is, it's beautifully simple. At every single intersection, it just asks one question. Which of my next steps appears to be closest to the goal? And then it just takes that step. It couldn't care less about the road it's already traveled. It only cares about what looks like the fastest way forward. Okay, let's see this thing in action. That little H you see next to each circle, or node, that's our heuristic. It's the estimated distance to the goal, G. You'll notice the goal itself has an H of 0. So the algorithm is always going to choose the path that leads to the node with the smallest H value. All right, let's walk through it. We start at S. The choice is between node A with an H of 9 and node D with an H of 5. Greedy says 5 is smaller, so boom, we go to D. Now from D, we can go to E with an H of 3 or B with an H of 4. Again, it greedily chooses the smaller number, E. And from E, it's a straight shot to the goal. Simple, fast, and hey, it found a path. But, and you knew there was a but, here's the catch. Being fast and impulsive isn't always the best strategy, right? This really simple approach has a critical and sometimes pretty costly weakness. Let's raise the stakes with a real-world problem. We need to find the shortest driving route across Romania, all the way from the city of Arad to Bucharest. Now, those numbers you see next to each city, that's the straight line distance to Bucharest, as the crow flies. That's going to be our heuristic. Okay, let's follow the algorithm's thinking. Starting from Arad, the best first move is to Sibiu. No problem there. But now, from Sibiu, look at the options. The algorithm sees that the city of Fogares is only 178 miles in a straight line from Bucharest. That is the lowest heuristic value you can see, so it eagerly zooms down that path, totally ignoring every other option. And this is where the problem becomes crystal clear. The path Greedy found is 431 miles long. But that wasn't the shortest path. The truly optimal route, the one that goes through Râmnicu, Vâlcea, and Pătesti, is only 418 miles. Greedy's clever-looking shortcut actually led it down a longer road. So, here's the key takeaway for our greedy friend. It is incredibly fast, mainly because it never looks back or second-guesses itself. It will find a solution for sure, but its laser focus on the quickest-looking next step means it can totally miss the best overall solution. But don't worry, this is where our second hero enters the story. Let's meet the A-star algorithm, a much wiser, more balanced navigator that actually learns from Greedy's mistakes. Honestly, the best way to think about A-star is with that classic fable. It basically combines the speed of the hare, that's the optimistic, forward-looking guess, with the slow, steady wisdom of the tortoise, which remembers the actual distance it has already traveled. And all of this wisdom is captured in a really simple, elegant formula. A-star looks at each potential step, each node, and doesn't just rely on the guess. It calculates a total score, F, which is the sum of two different values. G, the cost of the path so far, and each, the estimated cost to the end. So here's how we build our perfect navigator, G of N. That's our tortoise. It's the real, actual cost, the miles we've already driven to get to where we are right now. Each of n is our hair. The estimated, as the crow flies cost, from here to the finish line. A star puts them together to get f of n, a much, much smarter score that balances the journey so far with the journey still to come. Okay, so let's unleash this wiser algorithm on that same Romania problem, the one that tricked our greedy friend, and let's see what happens this time. This right here is the key moment. At Sibiu, remember how greedy was totally lured by that low guess for Pythagoras? Well, A star is smarter. It calculates the total score, the real distance we've already traveled plus the guess. For Pythagoras, that's a longer road traveled plus a shorter guess. But for Rymniku-Vilcha, it's a shorter road traveled plus a longer guess. When A star does the math, the path through Rymniku-Vilcha has a better total score. It chooses the smarter overall option. And just by making that one wiser choice, by balancing the cost of the past with the promise of the future, A star successfully navigates all the twists and turns and finds the true optimal 418-mile path. It's not just fast, it's genuinely smart. Now, this isn't just a fun little story about two algorithms. This core idea of using smart, educated guesses or heuristics is a cornerstone of so much of modern artificial intelligence. The A star algorithm and others just like it are working behind the scenes literally everywhere. They're helping robots navigate massive warehouses. They're powering the enemies in your favorite video games. They're optimizing global supply chains and even routing data across the internet. At the end of the day, that's what this is all about. AI often has to operate in a world where it doesn't have all the information. Heuristics give it the power to make intelligent, efficient decisions anyway, finding nearly perfect solutions without wasting time exploring every single dead end. And that brings me to a final thought for you. We've seen how AI uses these rules of thumb to make some really complex decisions. So what about you? What are the heuristics, the little shortcuts and rules of thumb that you rely on every single day to make your own smart guesses and navigate the complexities of your life?